All right, so any ideas about how we can connect them? Because the key insight here is if we know 2 points, we can graph the line, right? What does that tell us about graphing this line?
Any points that are on the line. It has to be specific because it's going down, right? Yeah. It has to be going to have to apply to the rule. So you could like sub in any value of x and then like apply it for the rule to find y.
Yep. And then that gives you 1 point. But is that enough to graph? So how do you get another point?
Don't you have to do since you find
you're on the right track. Okay, keep going.
Since you found 1 point, right? Depending on which point that is, it could be like x1 or x2 or 1, 1, 2, right? Depending on that point, since it has a constant gradient, you can find like the other one. Like if it's x2 you found, you can find x1, right?
You can, yes, technically, but
no, you can find them y2, x1, x2, and y2 because if you find 1 point, you can.
I think you're thinking too specifically because, like, finding a point is both x1 and y1. So you don't need to like think of it as specifically because you just need to find points. So she's given us a way to find 1 point. You just sub any value into the equation and you get another 1 point. So I think it's better to think about it in terms of more holistically in terms of points rather than just x1, y1. Do you understand what points are, right? Points is both, it's a pair of x and y, right? But it's good that you're thinking about this, but I think it's a little bit more simpler if you think about it in terms of the overall code. Does that make sense? But keep sharing these ideas because you can correct misconceptions through this. Okay. All right. So we'll go along your idea a little bit longer, which is the fact that if you sub in any x value into the equation, you get a y value. You have a point. Okay. So let's do that. What's the point you want to sub in? What x value do you want to sub? There's no right or wrong answer here. It's anything. 4. Yeah. Y is 4 plus 1, which is 5. So what's this coordinate? What's this point? 4,5. Does this make sense to everyone? How it's 4,5? Okay. Well, let me sketch that approximately. Let's say it's here. Okay, so it's 4,5. That's one of the points. But like, a lot of lines go through this point. Could be this line, could be this line, right? So we can't graph the line with just this point. What are we missing? Look, what was the observation we made here? We need second point. How do you find the second?
We set constant gradient of 4. So
yes, so you can use that. How would you use it? What's your idea?
Basically, when you have to find the change of x and change of y or change of x to find the constant gradient.
We already have the gradient, so how are we going to use that?
So basically, since we already have 2 points, which is is it y2?
We have 1 point, which is just.
Would that be y? Like y1 and y2.
It doesn't matter.
Okay, so since we already have that, we can find the other point by just using the gradient.
Can you tell me how though?
To find the gradient, you need to do like change of y over change of x to get you the gradient, right? So you need to find the other points. I think you'll find the change between like y, x2 and x1, right?
Well, what's our second point? We don't have a second point to find gradient. We already have a gradient there. Do you get what I mean?
Yeah.
So I think it's a good idea, and it gives us an idea of what this graph should look like because we have the gradient. But I think without the second point, good. Do you want to shoot? Yeah. Give me a second. Yeah.
two and three.
Yes, that would be a point. But how do you do so?
I think I have tissues in my
How
Yeah, I had tissues in my
oh, no, you go dry out, so right? Down there. Okay. Yes, you found 2, 3. What's the point of the line? How'd you find it?
Like, I'm not sure how I was trying to explain it, but you need to find the constant gradient, which we already have, which is 1, right? And to find the constant gradient, it has to be like 1/1 or like 2/2, which depending on what the gradient is, right? So basically, I just thought of like a specific number. If I wanted to get like two, I just did 4 minus 2, right? And then 5 minus 3. So that would be a coordinate, right? Like 2 and 3.
Oh, okay, okay. So since Nicholas knows that gradient is 1, what he did was he was thinking of different ways to get to that gradient of 1. So for instance, he did 2/2 to be a change in y over change in x to be 2/2. And if one of the points is 4, 5, right? So 5 minus y1 over 3 minus x1, sorry, 4 minus x1. He wanted these values to be 2 and this value to be 2, right? And from that, he got this y value of 5 minus y is 2, so y1 is, and x1 is. So he got 2, 3 that way. And it works. But I think there's a much faster way. Don't get me wrong, your way works. But there is a much faster way.
It's just like you can like sub in any other value.
Yeah. You have this equation here. Why can't we just we sub x is 4 here, right? Why don't we just sub another x? For instance, we could sub 2. And we'll get the same point as you did. Or we do a bit faster, right? Because you don't need to calculate gradient. But the same idea. This equation is a representation of this line. All the gradients and stuff is built into this equation. It's just a more summarized version. Think of it that way. Okay? So you can sub in x is 2 and then get y is what? 2 plus 1, which is 3. Same as you. So you're correct. But I think there's a more efficient way. And it just makes life a lot easier. Because look, if I give you a gradient like, I don't know, 1.6, to find that thing is a bit harder. But is it harder to sub into this equation if the gradient is 1.6? No. So the way you do it, it gets harder as the gradient gets more complex. But this way stays the same difficulty the whole time. Make sense? So the other point is 2, 3. And you just extend it. And then you have your graph. But here's the thing. A lot of the time in a question, when they ask you to sketch a graph, they'll have early on, when you start, they'll have a Cartesian plane. So labeling correctly along the Cartesian plane will be enough. But later on, you might need to draw your own Cartesian plane like you did here. And then things are no longer to scale, right? You don't know the scale exactly. So people could randomly draw graphs and then label points, right? So to sort of fix that, how your teachers will make sure you draw a relatively correct graph, even if it's not to scale, is they'll ask you to label intercepts. Okay, label intercepts. Do you know what intercepts mean? Intercepts are when? Close. That's intersection. It's a very close concept. It's quite similar. Intersection is when two lines intersect. Intercept is also an intersection, but not between two lines. It's
but a point.
Still lines. It's the line and the axes.
Oh.
So these are the intersections. The y-intercept, is the intersection of the y-axis and the line. The x-intercept is the intersection of the x-axis and the line. And you'll be required to find these intercepts and label them on your graph. How do you label these intercepts? I guarantee you on the test, every single question that requires graphing will require you to find the intercepts.
If you're trying to find the y-intercept, x has to equal 0, so you can sub it into the initial.
Exactly. You sub 0 here. Because look, y-intercept, what does that mean? It's perfectly vertical. There is no change in x, so the x value is 0. So you sub x equals 0 into the equation. Then you get y equals 0 plus 1, which is 1. That means my y-intercept is what? Yes, 0, 1 as a coordinate. Or you should write 0, 1. In a test, they might give you 1, but for you, write the proper coordinate. Okay, can someone else tell me how to find the x-intercept? The idea is quite similar. Yes, go for it. Spot on. Just like in the y-intercept, the x is 0. In the x-intercept, y is 0. So what do?
Switch.
Not quite. You have a point. Yes, y is 0, so you sub that in. There's no rule saying you have to sub in x's only. You can also just sub in the y value to find x. So you can sub y equals 0. And then what? You get 0 equals x plus 1. That means x is what? -1. Spot on, Kushal. Well done. Then what's my x-intercept as a coordinate?
-1, 0.
Yeah. Exactly. Any questions so far with this? Make sense? All right. Now, all in all, how many points did we need to find in this? 2. Yes, 2 initially draw the graph, but overall, how much did we end up finding? 4. Do you think that was a bit unnecessary? Yes or no? But at the end of the day, every single point we used was useful, right? We needed to use these two to sketch the graph. Then we use these two to label intercepts. Because the question will require you to find intercepts. Think of that as every question requires you to find intercepts. But is there still a way to find less points and sketch the graph out? Any ideas?
Midpoint.
Not quite. It's a little bit of a simple idea. There's nothing like brand new here. This is just more of a logical one. Because I can tell you right now, you can do only 2 points and sketch the graph with all the intercepts.
Just -1 and 0 and 2 and comma 3.
But then you still need to find the y-intercepts.
So you just need the 2 intercepts.
But then how do you graph?
You only need 2, right? Is it just 0, comma 1 and 4, 5?
But you need to label the x-intercept as well. You need to label both intercepts, but then you can still do it with 2 points. What do you think the idea is? How about instead, how we use these 2 points to draw the line?
Mm-hmm.
How about we just use these two? The 2 intercepts.
Yeah.
And then extend from those two. Is that what you said? Because I heard, so I thought you said 0, 1, and 4, 5, which is not these two.
No.
Yeah. Because I said any 2 points. So why don't you just find the two intercepts, and then use those two to sketch the line? Then you only need to find 2 points overall. Make sense? So that's what I'm going to recommend you do from now on. Okay, I'm going to give you a question to do now. The time 10:37. Let's say y is must be nice. 2x plus 4. The first point, and the second question is y is 3x minus. Oh, let's do negative 3x plus 5. Try to sketch the graph of this. I might give you a worksheet so you can have a transition point for one of them. Has everyone got their test backs?
I don't think I.
You can ignore these questions. You can use this as a Cartesian plane if you want. Oh, sorry, just 2 pages. You can keep it. I'll hand it out. Here's the first one. Ignore the question. Just use it as a Cartesian plane for sketching. As you can see, one of the questions has a Cartesian plane given, so you can use the scale on that. But the other one doesn't. Let's just test. Has anyone mistakenly gotten the Flash's test by any chance? Or maybe accidentally given it to you? Alright. What's the full bit? What ideas we discussed before, right? Try to apply them.
Are these are questions?
No, so ignore the questions on there. Do these 2 graphs, but use the first page as like the Cartesian planes to sketch if you want. Yes. You say that again?
Yeah, it's 2. Wait, do you sub?
You sub particular x and y values to sketch. Does that make sense? Like you can just sub in one value x and then find the y value. That's a coordinate on the line then. So that's a point on the line. Two more minutes, then we're done. 10 minutes. Our class is now shorter in terms of content. But next week onwards, be here at 9 sharp.
9 sharp.
class overall, I think everyone comes at like 9:05,
9.
except Kushal. He's here early. 9, right? I will stop going over time from now onwards because I want to respect your parents' time. So we'll stop at 11 sharp. But that means you also got to be here at 9 sharp. Awesome. Got it? So I'm a little confused by this. Why do you submit 2x? Or you want to just get this plus x? Yeah. But you're really subbing x is 3, right?
When you divide this by 2, you also have to divide like 4 by 2.
What do you mean?
Like to find x instead of 2x. So you divide this by 2.
No. So think about all you're doing is this. There's 2 unknowns here right now, right? You're putting in like a value for the unknown, replacing this unknown with a value, and putting in to find the y value that corresponds to that. So here, I think you should think of it as you're subbing 2x, subbing x values. You're really subbing only x is 3. I think I would not think of it this way. This will lead to confusion down the road. You're subbing x is 3, and then what's the y value if that happens? What is this, right? You add this up together. 10. It's not 7. I'm not quite sure how you get 7. But that's your y value. That's the coordinate. Makes sense? I think I would redo the other. This one's also not. Just replacing the x value with something in the equation. It's a -2. Oh, sorry, it's on the line. Yeah,
Will this become homework as well?
yeah, that'll be homework.
This will be homework.
Not that one. That's next week. Actually.
This one?
So it's just I was meant to do both topics, but I split it into 2 weeks. So today is just graphing. Next week is intersections and graphs as well. How do you know what to sum next week? It doesn't matter what you sum generally. If you find any 2 points, you just connect those 2 next time, right? But remember, the question requires you to also label the intercepts. So if you want to be time efficient, you should do is just sub in the 2 intercept points. And how do you sub in the intercepts?
By using one of these points.
What do you mean using one of these?
One of these points, either x1 or y1, x2, y2.
I'm not quite following that.
If you want to find the intercept, don't you have to sub in like a number from one of these points?
It's a known number. You sub in a particular number. It's not. Think about this. But think about this. On the y-axis, it's on the y-axis, right? What does this tell us about one of the coordinates?
It has to be on the y-axis.
Which means one of the coordinates is fixed. What's that coordinate? It's on the y-axis. It does not move horizontally. It does not move horizontally. Its x value is
either
It's only gone up vertically, right? So the y value is
Go
something.
down vertically.
What about the x value?
Oh yeah, it also has to be like cutting. Yeah, it has to be.
So
The
what's
x
the x
value
value?
has to be here, like on the
So-
x-axis.
But I'm talking about the y-intercept right now. What's the x value?
X value. Wait. Oh yeah, 0.
Think about it. You're not moving horizontally. X represents change horizontally. Only changing vertically. X value is 0.
And then the y value for x-axis is 0 as well.
Yes, for the x-intercept, y value is 0. So to find the y-intercept, you got to sub in 0 for what? For y. No. X. Y means no horizontal change, only vertical. So think of opposite. Y-axis, y-intercept is x0. X-intercept is y0. So you sub in those points to find the intercepts. Make sense?
Oh, and then it's a constant gradient afterwards. So
you don't even need to use constant gradient as much here. It does apply, but it's not something you need to think about necessarily. Because you just find 2 points, connect them. Do you need to think about constant gradient then? No, it's like connecting the dots.
Okay.
Make sense?
So
like if you have 2 points, right? I'll give you 2 points and I'll tell you if you guys have questions, feel free to let me know. I'll come around after. Think about this. I just give you 2 points randomly. Tell you. Draw the line that goes through these 2 points. Line, that's line segment. If you go forever, it means it goes beyond the 2 points as well. Do you think about constant gradient there?
no.
You just thought about connecting the dots.
Yeah.
That's all it is.
So do I just find like whatever point that is there?
Yeah, you just find 2 points and then you connect the dots.
Okay.
That's all it is. You don't need to think about too many things. It is, don't get me wrong, it does apply here, but it's not something you think about all the time. Yeah, exactly.
Are you supposed to be so? Why are you like supposed to be so?
What do you mean solving?
Like is it just like writing them on?
Yeah. So you label the points, but here's the thing, right? This is clearly obviously not the stuff, right? And that's fine to a certain extent. But you probably won't get full marks on this one because the scale is pretty far off what it should be. You want to be relatively to scale. And the reason is it's hard to beat, but it's hard to beat scale. So you know what tip you said? Instead of using these 2 points, they work, don't get me wrong. Why don't you use, because the question will require you to label the intercept and you'll get into trouble there because they clearly can tell they're not to scale, right? So what you do instead is you find the 2 intercepts as your original 2 points. Then connect those 2 and draw the graph. It'll be a lot more accurate. Yeah. Homework will be based on this. There'll be worksheet questions from page 17 onwards. I'll put them up on Discord. But yeah, no worries. Bye.
I think I screwed myself in for school.
What do you mean?
I had a house cat, and I had this one idiot who didn't know what to do.
Yep.
And he hasn't still sent me the video that me and this other guy created.
Yep.
And
it's like a
and it was due yesterday.
Surely it's not your fault. Tell your email. Tell your teacher.
Yeah, but then the teacher's gonna be like, "Well, you still had to do it."
But you've done it, so
yeah, but it was due yesterday.
So surely she'll be nicer. Yeah, you can. They'll be pretty reasonable. If it's not your fault, if it's your teammate's fault. Okay, it's 10:50. We're actually gonna wrap it up there. Oh, you're taking? Okay, that's good. Yeah, 10. Okay, we'll actually wrap it up there. From this week onwards, we're finishing at 11 sharp. So we're gonna do a Kahoot now.